Hello and welcome to this first tutorial in using WebMap at Home. What I'm going to begin with is by giving you a brief overview of space syntax and WebMap at Home and show you some of the facilities that are available, and then other tutorials will show you some of the more facilities in greater detail. So I've just launched WebMap at Home and I'm going to start off by loading in a classic axial map. This one is London. So the first thing I'm going to demonstrate here is the ability to zoom, and here we have a map of central London. This is very much the kind of traditional map that geographers kind of work with. It's a map of space. So this line here, for example, represents Oxford Street. This line represents the traffic around Regent's Park and the access to London Zoo. Then you've got other major roads, and over here we have the City of London, and this edge here represents the River Thames. So this is generally what people have when they look at urban data. They just have a series of sort of spatial representations, a series of axial lines in this particular case, and we'll come to the definition of axial line later. What can you really understand from this map? What can you decide? For example, if you just looked at this map, where are the busy streets? Where are the quiet streets? Where are the back streets? Where are the neighbourhoods? Well, let's process it and see what the syntactical processing suggests. Now, while that's happening, I'm just going to load up the preferences and change the background colour to black. And I'm going to look at integration. So integration is one of the classic measures of space syntax. And this is a measure of the global movement through London, assuming this was an accurate map of London. What we see here is that Oxford Street pops out as the reddest street. Now, you saw in the black and white version exactly what the machine knew. It knew that there was a street here, it knew there was a connection, but it didn't know anything else about Oxford Street. But by processing it via integration, it actually decides that this is the most central street in London. And I'll come back to a better description of how space syntax processes this later on. Equally, we have streets like Tottenham Court Road coming out as major integrators. What we see here are the numbers of space syntax that have just been cast back into colour. Let's zoom out slightly. And this is a measure of centrality. So basically this is just saying, if this was a city this size, what would be, with this extent, what's the most central street and what's the most peripheral street? Globally, this would say this is the busiest car street, for example. What we can do with space syntax is reduce the radius to radius 3 integration, and this gives us a better description of what things are like locally. Let's zoom in a bit more. So again, Oxford Street is still the busiest street. Like, that kind of correlates with reality. This is a busy shopping street. We see streets like Tottenham Court Road, again, are very busy streets, and again they're actually quite busy shopping streets. We can move up here to the Camden region, and we see that the street in Camden is also a busy pedestrian footfall street. If we go to one of the classic areas of space syntax, this area is known as Barnsbury. Over here, if you have a map of London, this is Islington. This is a very kind of busy, hip and quite pricey area. We can see that the yellows and brighter greens pick out the busier streets, and then the blue pick out the cut off and less busy streets. So for example, this is a historic map, so this is actually King's Cross as it was before the redevelopment. We can see this street here is actually very quiet, very dead street, which actually historically was. Okay, we have other measures in WebMap at Home. For example, we have fractional integration. So this gives you a measure of integration but this time based on angle of axial line incidence. So for example, if we jump from integration, you see that this street, which is Oxford Street, New Oxford Street, then goes into Theobald Street, and it kind of dies off pretty quickly. With fractional integration, I log it, you see that this street remains this busy street, and that's because of the various computational processes involved, but it actually reflects the kind of meandering nature of these streets and how they function in the larger system. This stuff has then been developed onto the more angular measurements, which are the basis of segmental analysis. So what facilities have we generally got in WebMapAtHome? Firstly, obviously we have the process to process the axial map via doing it. We have facilities for creating axial maps, and we have facilities for analysing the data of those axial maps. Let me briefly go through for some of the facilities. We have a line inspector. This just tells us the information about that particular line. So let's go back to Oxford Street. Let's pick Quiet Street. So this actually just gives you the individual values for that particular axial line. We have a histogram, and this looks at all the axial lines and gives you a distribution of the various values. So here we see there's a large number of cut-off streets and a small number of very integrated streets. Let's not log that. This legend gives you a value of what the colours mean. The colours are inverted here, so they actually go from minus number to minus number, and that makes the most segregated one blue and the most integrated one red. Sometimes you want to invert that, and we can actually just do that by reversing this. If we look at the histogram, we see now red is the more busy one. We see the numbers are positive, and at this point the map is inverted, so blue is most integrated and red is most segregated. There are lots of tools here for playing with the colour scheme of the axial map, and that can be quite useful in terms of understanding what's going on. For example, we can do a similar one looking at the reciprocal. So again, this inverts the colour scheme, but if we look at the histogram, it squeezes the histogram in a different way. Let's actually do both simultaneously. There we go. And again, you can see here we actually have more integrated lines, and that basically allows us to look at the differentiation in the blue lines with a bit more detail. You can actually see some of the subtle variations in the segregated lines. Let's just go back to the normal measurements. We also have scattergrams. So for example, one of the more important measurements in space syntax is the idea of intelligibility. This scattergram allows us to look at the distribution of axial lines. So for example, each node here represents a certain degree of connectivity, and the vertical axis is the certain degree of integration. So here, for example, we have a street which is both highly integrated and highly connected. I'm just going to switch back to black, the color on black mode, and you'll see the selection a bit easier. See, it's got black handles here. So not surprisingly, we can see that the most integrated line is also the most connected. Now, a lot of people actually confuse the two together. They actually say the most connected line is the most central, and actually is not true. For example, this line is highly connected but highly segregated. Let's select that one, and we'll just zoom out a bit so we can see it. Let's play Hunt the Axial Line. Oh, here we go. It's down here. And that is a high street. I think that's King's Road, if I'm guessing right. So King's Road is highly connected, but in this case it's very on the edge, so that it's actually quite segregated. So there's no strict relationship between connectivity, number of connections, and how important you are in the system, and that's an important concept we can come back to later. We can also select groups of lines and actually find out where they are. So this works both ways. If you select something here and cause this to refresh, you actually see it. Let's just select this one. Oops. And cause this one to refresh, you'll see it gets selected here. Okay, the reflection process, the selection and refresh process isn't perfect, but you can manage it, and it's a piece of free experimental software. What do you expect? Up here we have the navigator, and this allows us to walk around the axial map, which is particularly good if you're very strongly zoomed in and you want to investigate various pieces. Along with the scattergram, we have a table view, and this basically just tells you what the values are in a sorted table. This is a bit like one column in a spreadsheet, and you can switch columns to look at the various numbers in detail. There's a column calculator, and this allows you to do calculations on columns. So, for example, if you wanted to multiply integration by another number, let's say connectivity. Okay, so let's go back up here and look at the map by connectivity. So this is the number of connections you have. We'll zoom out again, give it a bit of a view. And this is going back to front, so it's making the most connected blue. So what we'll do is we'll reverse that process. And now the most connected is the red lines. And with the column calculator, you can actually say multiply. You can actually say, for example, create the square of connectivity. So let's take integration connectivity c squared, and we're going to multiply it by connectivity. And then yeah, and unfortunately I can't see the button. Okay, we'll come back to this when I can zoom the world out. There are other controls, for example, what radius x is, what's the fractional radius. We'll come back to that in later on. Backgrounds is quite important when you come to actually creating the axial map. This basically allows you to have an image that you can draw on top of. There are layers, and again we'll come back to that in another lesson. Connections actually allows you to look at the kind of connectivity between lines. There's an optimizer and the intelligent surface. They're quite experimental and quite advanced. And finally, we'll just come back to document info. Basically, Axeman had this meta information system that allowed you to actually store information about the particular line with the file itself, so it wasn't get lost. At the top here, we have a number of calculations that can get done. We'll cover those in a later lesson. We can generate axial maps, and there are a variety of tools to help you drill down into the data and explore the information you've got. Okay, well, that's quite a lot to be going on with, and we'll come back to a lot of these facilities in a later lesson. Thanks for watching.